So let's formalize that a little bit. And this is actually called end behavior. So what we're saying is as x goes to infinity, and so here's the x-axis going to positive infinity. So as we put in bigger and bigger values of x, our function is headed to plus infinity. So what we say is, as x goes to infinity, f of x goes to positive infinity. And in the other direction, if we want to look at what's called end behavior as x goes this way, so this is you're headed down the x-axis this way, so you're getting more and more negative, although the actual number, the magnitude of the number is bigger, so like minus 100,000 to the function, or the y value, as we put in more and more negative x values, well, it's also going to positive infinity. And so as x goes to negative infinity, f of x, the output, goes to plus infinity also. And remember that every single one of these points on here is an x value and a y value. So as this number is headed towards negative infinity, we're saying this number is headed towards plus infinity. And you can see that in the table also. So let's look at it for this quadratic. So as we put in bigger and bigger, oops, I should use the same color, as we put in bigger and bigger negative values, what's happening here is it's headed to minus infinity. And on the other side, as we put in bigger and bigger x values, as we go further along, it's also headed to negative infinity. So as x goes to plus infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to negative infinity. It's a lot of words. So these are both even degrees. And that's nice. The even degree part tells us both end behaviors will be the same. Okay, but they're obviously different. The one on the left goes to plus infinity and the one on the right goes to negative infinity. Well, that's because of the leading coefficient. So the other key is the leading coefficient, which over here is -1, and over here is +4. So first thing is degree, and second thing is leading coefficient. If the leading coefficient is positive, then it's going to head to positive infinity. And if the leading coefficient is negative, it's going to head to minus infinity. So those are the two rules for even functions. Odd functions, same idea. So I want to look at what happens as I traverse out here and put in bigger and bigger bigger and bigger positive x values. Well, as I keep going up this, it's going to plus infinity. And if I head this way on the x-axis and put in more and more negative, so larger value, more negative inputs, and I'm headed this way to negative infinity. So this is degree 3, and leading coefficient +2. And what I see is that as x goes to infinity, f of x, the output value, and again, just to remind you, x sub n comma y sub n, input output, or we might call it x sub n f of x, the nth value, It's always a pair. So as I put in bigger inputs, what is happening to my output value? And it is getting more and more positive towards infinity as my input is getting more and more positive towards infinity. So as x goes to infinity, f of x goes to infinity. And as x goes to minus infinity, f of x goes to minus infinity. So the first part of the rule, for odd degree and behavior is opposite. So even is the same on both ends, and odd is opposite. Now what does the leading coefficient do? So over here in our example number 4, our degree is still 3, which is odd, and our leading coefficient is -1, so it's negative. On this side, as I put in larger and larger positive x, what's happening is my function is going to negative infinity. And as I put in more and more negative x, my function heads to positive infinity. So one way you can think of this is they're opposites. As x goes to positive infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x goes to positive infinity. So if the leading coefficient is positive, your end behaviors are different, but they match. So with x going to infinity, f of x goes to infinity. And if it's negative, they're opposite. And I personally find the words, like all these words, a little bit harder than it really is. What you want to do is make yourself an index card or a little resource, or print out these notes. Something just to have this as a resource while you practice. Okay, so let's make ourselves a little chart here. So if we have an even degree, positive leading coefficient, then we're going to have is end behaviors that go like this. They both go to plus infinity. And if we have an even degree negative leading coefficient, our end behaviors are both going to go to negative infinity. If we have an odd degree positive leading coefficient, they're opposite, but match x. And if we have an odd degree negative leading coefficient, they are opposite, but they are also opposite of x. And so just to make a little, remember that we're talking about the axis here. And so this is x going to positive infinity, and this is x going to minus infinity. So just remember that part. All right, so we've got here a couple practice things. Determine the sign of leading coefficient and whether it is even or odd. All right, so these go in the same direction. That's headed to minus infinity, minus infinity. Since they're the same, it's even. And since it's headed to negative infinity, the leading coefficient is negative. All right, this one, as x goes to negative infinity, the function goes to negative infinity. And over here, with x going to positive, the function goes to positive. So therefore I know that it's odd. And I know the leading coefficient is positive because they match. X and f of x are both going to positive infinity.